Okay, so by request, I'm going to go ahead and spend a little bit of time going over like a little bit of a mock quiz. This will look actually phenomenally similar to the one that I want to give you because it's pretty straightforward. It's always the same kind of questions because it's just knowing the basics. It's on sections 4.1 to 4.3, the beginning of some unit circle stuff. And so here we go. Let's go ahead and take a look at it. I also will have just the answers. So one of the things that I wanted you to remember is that all of this is predicated on a couple of pictures and the unit circle in general. So remember that this coordinate is 1, 0. So the angle 1, 0 goes to 1, 0. The angle pi over 2 goes to 0, 1. We've got negative 1, 0, and 0, minus 1. These are what we call the quadrantal angles. So we have that at play. That's going to affect these answers right here. We also know that the sine, which is always the y value, the cosine, you don't need to put these in here. I'm just explaining. And the tangent is y over x. But as it turns out, all we're doing is reflecting the answers to some questions and then moving them in here. Is that if you took a 30, 60, 90 triangle like this, where this is 30 degrees, also known as pi over 6, this is what we did back in math too extensively. This is a half, that's 1, that's a half, because it was an equilateral triangle that was split in half and root 3 over 2. In a similar way, if we took a 45, 45, 90 over here, which this is again 45 or pi over 4, it's isosceles. Pythagorean theorem makes those all root 2 over 2. So every piece of data that I'm going to establish in here is just the information that we have right here. So there's nothing magic. It's just a nice, easy way to demonstrate it. So the way I've had people do that, I'm going to do in blue so you can kind of see what I'm after. But it turns out the sine being the y value, the sine of 0 is 0. And then the sine of pi over 6 right here is opposite over hypotenuse. It's 1/2. But I had a little bit of a fancy path to do. So you could get all of this information right off of these three things right up here at the top. But somebody showed me a long time ago that if you start here and you start at 0 and you start counting 0, 1, 2, 3, 4 in theory, and then we take the square roots of all these numerators. Notice I don't need to take the square root of 0 or the square root of 1, and then I divide everybody by 2. As it turns out, the answers to all of these questions about the sine are going to be right here. See how the sine of 0 is 0, the sine of pi over 2 is 1 because the sine is the y value. Notice the sine of pi over 4 opposite over hypotenuse, the sine of pi over 3 opposite over hypotenuse. It's all right there. It's a nice simple way to do that. So sine goes 0, 1, 2, 3, and theoretically 4. But root 4 over 2 is 1. So 0, 1, 2, 3, 4, divide by 2, and then take square roots. And then the cosine is really the same thing. It just goes in reverse order. So it's 4, 3, 2, 1, 0. Notice no need for square root of 0 or square root of 1 because it's redundant. And then since the sine is y and the cosine is x and the tangent is the quotient, we just divide. And 0 over 1, 1 over 0. Anything divided by itself is 1. And then these are a little harder, but if you do them once or twice, you kind of just know what answers you're looking for. Now, what makes this really convenient is now we have pretty much every answer I could ever ask for right here. So this is kind of the body of where the questions are going to be. So the sine of any kind of pi over 3. Well, let's see, where is that? So if I count negative 4 pi over 3, I'm going to go backwards, 1, 2, 3. Well, a little bit more would make 4. And you're going to notice that I missed by exactly 1 pi over 3. And I know we had a little mnemonic device, and again, not necessary, but we said all students take calculus or a stupid trig class, that based on the fact that the y value is the sine, the y values are positive on top. So notice the sine is positive in these two. The cosine is the x, so it's only positive here and here. And so anyway, I'm already done because it's in the second quadrant, and I know the sine is positive there. The tangent of 11 pi over 6 is root 3 over 3. It's sitting right here. The tangent of 11 pi over 6 is right there. Now, I do need to find out if it's a positive or negative. So if I count forward, 6 almost 12 pi over 6. Remember, 6 pi over 6 every time is a full pi, or 6 pi over 6. Notice that's in the fourth quadrant. Well, in the fourth quadrant, the sine and the tangent are both negative because just the cosine is positive. So this is going to be assigned a minus answer. Now, this is a little bit harder. The secant is the reciprocal of the cosine. So the cosine of any kind of pi over 6 is right here. So this would be 2 over root 3, also known as 2 roots of 3 over 3. That's a little bit of work. We had to rationalize that. And I'd have to decide where it is. So 6 pi over 6 would have been all the way here. And notice again, I missed by exactly 1 pi over 6. That's its reference angle. And so we know that the cosine in the second quadrant is a negative because the sine was the positive one. So I'm going to assign a negative answer here and here. So I'll just keep going. Let's go through the whole thing. The cotangent, I'm going to find the tangent of pi over 6, but the cotangent is the reciprocal. So that's going to be root 3 if you do a little bit of math to kind of fix that. And 7 pi over 6, that would be 6. So 7 is a little bit more. 6 pi over 6, I'm counting by 6s. And I know that the tangent is positive in the third quadrant, so the cotangent is positive as well. Now, this is called a quadrantal angle, and this kind of bothers people a little bit, but we'll see what we can do. 11 pi, well, pi is 180 degrees, so it's saying let's do 1, 2, 3, 4, 5. Well, that's a lot. Every 2 pi is a full circle. So if I did 11 pi, that'd be 5 full circles, boom, plus 1 more. 11 is going to be facing this way. So we can use this chart. I know it's right on the axis, so its reference is going to be 0. So the cosine of 0 is 1. But since it's going to the left, it's going to be a minus 1. Okay, moving along. The sine of any kind of pi over 4 is root 2 over 2. But we just have to start thinking. And sometimes people draw the circles, and sometimes they just kind of keep track in their head. So this would be 4, 8, 12, 16, 20. So 4, 8, 12, 16, not quite 20. It's in the second quadrant. And we've seen this a few times now. Since it's in the second quadrant, this should be a positive. And I don't know why I wrote it that way. That's root 2 over 2. I don't know why I wrote that. So let me fix that. That's root 2 over 2. Okay, now let's keep going here. The sine, remember a cosecant is a reciprocal of a sine. So if the sine was a half, then the cosecant would be 2. And so if I rotate down 5, not quite 6 pi over 6, it's going to be negative because, again, the sine is only positive in the top 2. Again, the sine of any kind of pi over 4 is root 2 over 2. That's where I messed up down here. And so if I rotated to 5 pi over 4, right down here, 4, 5 pi over 4, this should be a negative, but there's a negative here. So it's saying subtract a negative, so that's a positive root 2 over 2. So the negative is here, but then this negative comes from the quadrant. Okay, I'm going to flip root 2 over 2 over, and that gives me root 2, believe it or not. And then again, 4, 8, not quite 12 for second quadrant. I know that the sine is positive in the second quadrant, so the cosecant is positive 2. The tangent of pi over 3 is root 3. Now this is kind of weird. There's a negative out here, right? So I wrote that here. And it's saying rotate backwards, so that's be 3, 6, 9, 12, 15, not quite 18. So that was a positive. So a negative times a positive is a negative. So this one would be minus root 3. Now, one thing that I will sometimes do, and again, you're not really supposed to use a calculator, but as you're practicing, sometimes it's a good idea to double check your answers. So I got negative tangent of negative 17 pi over 3. Now, I found that I think my answer should just be negative root 3, and let's see if it was. So I got this decimal, and let's find out if that is negative root 3, and I see that it, in fact, is that entity. So, moving on. Now, reference angles, this is kind of going backwards. This actually should have been the first question, but Because most students really like this little chart, I put that at the top. So this is asking you where it is, and a reference is what you missed the x-axis by. So if we did it, this would be 6, 12, not quite 18. 18 pi over 6 is here. We're at 17. We missed by 1 pi over 6. That was fairly easy. We've done that above. But this is not a unit circle easy problem. So if we're counting by 8s, this would be 8 pi over 8. We're not there. 16 pi over 8, we're getting closer. I'm off by 3. If I kept going, it would be 24 pi over 8, which, again, this is 3 off. This is 5 off. This is closer. So 3 pi over 8, because the definition of a reference angle is the closest angle you can get. Now, keep going. 532 degrees is the first one I gave you in degrees. This would be 180. This would be 360. I'm getting closer. This would have been 540 if I kept it going. Well, how much did I miss by? It was exactly 8. And a reference angle is an absolute value. So you miss by 8 either up or down. It doesn't matter. It's just you miss by 8. And then the last one was just to be a little bit mean. You're supposed to reduce all fractions. So 7 pi over 3 is a unit circle problem like the ones we talked about here. So we don't even need to think, but to show you, 3 pi over 3, 6 pi over 3. Notice I missed by exactly 1 pi over 3. So going to the back page, it says let's name the quadrant. So where is this? So let's see. I need a cosine that is positive. Well, a cosine that is positive cannot be in either of these two. And I need a tangent that is negative, so it can't be in the first quadrant because everybody's positive. So it must be in quadrant 4. Let's go to this guy. It says the secant is negative. Well, if the secant is negative, that makes the cosine negative. So it cannot be here or here. But I want the sine to be positive, and that happened in this one. So that's quadrant 2. Remember, the sine was quadrant there. And this is the tricky problem. That's why it says quadrant plural, possibly. Where is the sine negative? Well, it can't be here or here because the sign is positive. So this actually happens in both quadrants 3 and 4. And my final question on the quiz right here is to try to come up with everything that we could have. And there was a typo. Well, actually, once there was a typo, it's been fixed. But I need a negative cosine. So it can't be here or here. But I also need a positive tangent. So that means it has to be here because that's the only place where the cosine is negative, but the tangent is positive. So we draw it like this. Remember, always attached to the x-axis. The definition of cosine is adjacent over hypotenuse. If I did a little Pythagorean theorem, because you may not recognize that, but let's see, 17 squared minus 8 squared, square rooted is 15, but you might recognize this number because we've done it in class before. Now, as it turns out, this time they're both negative. And they're negative because this one is going left and this one is going down. Remember, left is negative and down is negative. Up and right are positives. And so we just have to finish because it says, what is the sine? So even though the angle is really here, we really look here. So the sine is opposite over hypotenuse. The cosecant is the same thing but flipped over. The tangent is positive 15/8 because a negative over a negative is a positive. Cotangent is the reciprocal of that. And the secant, of course, is just the reciprocal of the cosine. Now, as a quick double check, all students take calculus. We should know that in this quadrant, quadrant 3, only the tangent is positive. And what you look right here, notice the tangent and the cotangent are positive and all the other guys are negative. And that kind of finishes up my answer key. So hopefully that helps and your quiz will be somewhat similar. Bye.